keep these things open. And you don't need to have the other person pick up the phone. The channel is provisioned. So any new connection attempt is going to be blocked by the network saying, hey man, we have already 10,000 calls who are going to be set up just right now. Please try back later. You ever hear this message? Probably some configuration in the release of the call. Then, call release flow. Okay? Disconnect my phone. The SS7 system sends a release message. Disconnect the other phone, and then does a confirmation of the release. Attack quiz. Any idea? Oh, okay. Fujitsu. Is it?
If you don't confirm, the code will stay open forever.
That's one, yeah, that's improvement of the previous attack, correct. That's the way that that you can actually know. The release here is not the confirmation. You said you can confirm the call?
If you don't acknowledge the fact that you release the code, then I think the other side will wait for your acknowledgement for it.
Yeah, but here you're thinking about some real connection. So yeah, that's true. You can actually disconnect one hand. And that's the way. That's giving out of service on a selective number. So you can disconnect anybody on the network. That's true. So that's it. Basically, with one packet, you can actually disconnect a live phone call between two people. You can disconnect the two. Even if you do one of or the other, one guy is going to be disconnected. So you don't care if you're sending REL or RE. Actually, the operators in the days used something that was funny. They were able to inject themselves into one live conversation and even disconnect one call and call just after. That's how they did it. They just disconnect the call by injecting the equivalent of RLT and then connecting to the person that was disconnected. Selective linear service. Also, what is funny is that by injecting message from the map perspective, so here we're putting SS7 on the mobile phone, you can do, for example, message such as send routing information. And SRI is going to reply you with some information such as this guy has this roaming number, so you can call him for cheap in this network, is connected to that MSC, so you can see in which part of the town or in which country the guy is. Just by having this lookup done on, let's say, HTTP API provided by some provider on the internet, you can do 10,000 lookups like that, and that costs 150 euros. This is used by SMS spammers who are sending SMS only to verified phone numbers who are not roaming. So basically, this is generating a lot of revenue for the operators that open their gateway for this kind of messages. Now, you can use that for privacy tracking. If I'm using that on all the phone networks in my address book, I know roughly where everybody in my address book is. And that's a little problem because it's available to anybody in the street. You can probably guess that this has been done for years by some people who have better access. Another funny way to attack this map is actually to do a location update throw. This is when you're going to do a location of a guy who is visiting, let's say, okay, one country in Uzbekistan, and you're going to make it go to Russia. Actually, he's not in Russia. If he's in Russia or in France and you make it go to Taiwan, wherever, if it's not the same country or even just not the same operator, it's going to work very well. So basically, you just need the IMSI, which is obtained through the first send routing information packet or request. And then from there, you're going to attribute his VLR to some other number somewhere. So here, for example, let's say that we give now a new VLR which is in Russia. And what happens from there is that all the calls to this customer are going to end up not in France or Kazakhstan or Taiwan, but in Russia. If you complete the mission a step further by controlling the equipment in Russia, you get the calls, you get the SMSs.